In this video series, I work through a math problem each video. In this problem, we want to match up the postulate for real numbers written in the right column with an expression that represents an example of that postulate in the left column. Let's look at the postulates first. All these postulates come in pairs, one for addition and one for multiplication, except the distributive property. We need to keep in mind that addition and multiplication are binary operators, meaning that they take two numbers, combines them together somehow, to give a single number as a result. The closure postulate states that when we carry out the operation on two numbers, the resulting number is also of the same type. So when we add two numbers together, we get a real number, and similarly, when we multiply two numbers together, we get a real number. The commutative postulates tell us that the order in which we add or multiply numbers won't affect the result. If we switch the order of the two input numbers, we still end up with the same answer after adding or multiplying. The associative postulates deal with the situations when we add or multiply three numbers together using two addition signs or two multiplication signs. These postulates tell us that in these situations, it doesn't matter which of the two operators we calculate first. We'll end up with the same answer either way. The identity postulates tell us that for both addition and multiplication, we have special numbers which won't change the other number when we add or multiply. For addition, that number is 0, and for multiplication, that number is 1. Finally, the distributive property is the only property that uses both addition and multiplication. It tells us that we can split up and distribute a number and the multiplication sign to each of the two numbers added together inside a set of parentheses. Now, let's look at the expressions from our problem. The first expression has 5 multiplied by 7 multiplied by 2. But on the left-hand side, we have 7 multiplied by 2 inside the parenthesis, so that's what we want to calculate first. And on the right-hand side, we have 5 times 7 inside the parenthesis, so we need to calculate that first. This equality tells us that either way, we end up with the same result. Since we have two multiplication symbols on one side, we are working with the associative postulate. And since we have we're working with multiplication symbols, this is the associative postulate for multiplication. Next, we have the expression 11 multiplied by 2, and the symbol next to that is from set theory, and what it means is, quote, is an element of. So 11 times 2 is an element of a set, and in this case, the set we're dealing with is real numbers written by just R. R represents real numbers. So this tells us that if we take two real numbers and multiply them together, we end up with a real number. This is the closure postulate, and since we have a multiplication, so we can say that this is the closure postulate for multiplication. Next, we have 17 multiplied by 1, and that's equal to 1 multiplied by 17, it's equal to 17. So what this tells us is that 1, it acts as an identity. If we multiply 1 by some number, we get that other number. So this is the identity postulate, and since we have the multiplication symbols, this is the identity postulate for multiplication. Next, we have 5 and 3 added together just in the reverse order, and the equality tells us that we still end up with the same number. So this is an example of a commutative property or commutative postulate, and since we have addition, this is the commutative postulate for addition. Next, we have 11 plus 0, which is equal to 0 plus 11 equals 11. So 0, when added to any other number, or in this case, the particular number we're working with is 11, we end up with 11. So this is the identity postulate for addition. Next, similar to what we had before with 11 multiplied by 2, we have 6 plus 8 is an element of a real number. So this is a closure postulate, meaning that we start with two numbers and if we add them together, since these two are real numbers, we end up with a real number. So this is a closure postulate for addition. Next, we have the special identity that combines the multiplication and addition together in a single postulate. The number that's written to the left of the multiplication sign, 8 multiplied by, this part is repeated twice on the right hand side. So 8 multiplied by this part is distributed to each of the numbers inside the parentheses, 6 and 3. Both 6 and 3 get 8 multiplied by. So this is the distributive property. Next, we have 3 plus 8 plus 2, but we're adding 8 plus 2 first on the left hand side, and on the right hand side, we're adding 3 and 8 together first. So this is the associative property, and since we have addition, so this is the associative postulate for addition. Finally, we have two numbers, 7 and 8 multiplied together, but in different orders. And this equality tells us that they're equal to each other. This is an example of the commutative postulate for multiplication, since we have the multiplication sign there. So this is